Good day. On this lesson, I'll be doing life science term 3 test for grade 11 in Limpopo province. So without wasting any time, I'm going to go straight to the paper. So the paper was 1 hour for 60 marks. So the first question on the paper was lovely multiple choice. So as we know, with multiple choice, we'll be given 4 possible answers. So what I always advise learners who are doing life science, physical science, geography, agriculture, or math, like the most important thing is to read the question first and then go and eliminate all the answers which will be obvious one out. So we have been told that the maximum number of individuals that can be accommodated by resources of a particular habitat. So they're asking us about the maximum number of individuals which can be taken by a habitat. That will be the carrying capacity. So if the carrying capacity is 100, therefore we can't have more than 100 animals in that habitat. So the maximum number that a place can take people, we call that carrying capacity. 1.1.2, which one of the following represent density dependent and density independent factors? So here the aim was for us to know what are density dependent, what are density independent. So we know that disease and competition, they are, yes, dependent factors. Flood and drought, yes, they are independent, those ones. Fire and flood, no, they are independent, so they can't be under dependent because they are independent. So this one is out. They can't be under dependent, they're independent too. This is dependent, but now they're putting it under independent, meaning it will be out. And then food supply and disease, that is will be falling under independent, and then competition and competition will be under dependent. So this one will be under dependent. So again, this option will be out. And then we've got competition and fire. Again, fire is under independent, so it can't be under dependent. This one is, of course, it's under independent, but we've got fire, which is under dependent, so it's wrong because of that. So the only one that is correlating with everything is option number A, which is that and also that. So option A is the one that is correlating for both dependent and also independent factors. So our answer will be A for that. So here the aim is for you to know examples of dependent factors and also examples of independent factors. Then you'll be able to tick out the ones which have been put on a wrong column. 1.1.3, we're being told that a decrease, yes, that's very important to note, a decrease in population is due to, remember, we know mortality is death, so meaning death will lead to decrease in numbers. If a population was having 100 people and then there were 30 deaths, people now will start decreasing because of that. Also, emigration is the movement, so people are leaving that population. So emigration is the movement, people are leaving that population. Emi means coming inside, and whenever people are coming inside, they will increase the population, they won't decrease it. So that one is out. Same as this one is giving birth. Giving birth will increase population size, so meaning it's out. Because they're asking us about decrease in population, only emigration and mortality will decrease the population. So the correct option of wrong figure number 1 and 4 is letter A. That will be the correct one. So if tomorrow the question was asking you for increase, if they're asking for increase, increase would be immigration also, natality. This will be the one that will increase. But for decreasing would be immigration and mortality, which is letter A. So we only have 3 multiple choice questions. Okay, now play. Let's go to 1.2, which are the biological terms. So we need to go and read every word and give the correct term for that. So we're being told that a muscular sac which stores urine temporally, we know that is the bladder. So the sac will be the bladder. That will be the bladder, which will temporarily store the urine. So it's the bladder. That will be the bladder there. That's temporarily store the urine, the bladder. That's R there. And then a method of using a machine to remove waste products from the bloodstream if the kidneys are unable to do it. So whenever we're using a machine, that's dialysis. So whenever you're using a machine, that's dialysis, which is used to assist if the kidneys cannot do the function. So it's dialysis. That will be how the kidney will be assisted by machine is dialysis. A group of organisms of the same species living together in the same habitat and capable of random interbreeding. Group of same species, that's population. That's population. And then a group of individuals who can interbreed and produce a fertile offspring, that would be species. But a group of species becomes a population. A group of species becomes population, and then a group of population will become a community, and so on and so on. So only again we've got 3, okay. Maybe because the term 3 test, but mostly for exams you get like maybe 6 or 8 biological terms. So now let's go to A only, B only, or none. So we've got column A, column Roman figure 1, and column Roman figure number 2. So firstly, we are being told a simple sampling. Simple sampling is that one where you can count, we can take a large population. So the one that will take a large population here would be indirect technique. So simple will be indirect. So it will be indirect, which will be A. So our answer will be A only because it can't be direct. So we can say that will be A only there, because that will be simple. Then changes in species composition over time in a habitat that was not previously having an organism. We call that ecological succession. That is ecological. So option A is symbiosis, habitat. No, our answer is ecological succession, which is not there. So the answer will be none, because that answer should be ecological succession, which is not there. So it will be none, because we've got 9 of them. And then let's go to 1.4. 1.4, we're given a graph which is showing pattern of bacterial population over 24 hours. They grow so fast. Imagine within 24 hours, you've got a population that's growing and then it dies afterwards. Okay, so remember it's an S shape. The shape is an S shape. So we're given an S shape. So from there, you need to know that the first phase here is the leg. We call it the leg phase now. So for the first one, that is the leg phase. And then we go to exponential here. That will be exponential. So, okay, before I fill them up, just get the answers. So the one that's to find phase for option A, which is this one. So A will be the leg phase. That's the leg phase. Yeah, because the thing is 1 hour, so I want to also finish it within 1 hour. I don't end up wasting time filling up things that are not required. So that will be the leg phase now. That's the leg phase. And then option B, they're asking for phase in D. That's the last one. So phase in D, we know that is the equilibrium phase now. So mostly we call that the equilibrium phase, where it becomes stable. So it's the equilibrium phase. That's the equilibrium phase where the whole thing becomes constant. So that's the equilibrium phase. So C will be the deaccelerating phase. That will be C. They didn't ask for C equilibrium phase. So C is what we call the deaccelerating phase. They didn't ask for it here. And then B, we know it's exponential phase. So they won't ask us for A and D. Maybe in the next coming exam, they're going to ask for B and C, or for all 4. So it's always good to know all 4. So A is leg phase, B is exponential phase, C is deaccelerating phase, and then D is equilibrium phase. During which phase A, B, C, or D did natality exceed mortality to the greater extent? So where they're saying, where are we getting more birth rate than death rate? This means they're asking us, where are we getting more birth rate than death rate? You can see there that the biggest growth or the biggest birth rate is in B, the exponential phase. So B is the one that you're going to get more birth rate. That will be B. So B, you get more birth rate. And then now the birth rate start decreasing a bit here, then here it will be equilibrium or constant. So B, that's when you get more birth rate. Explain why growth slows at C. So the reason why the growth is slowing down at C, which is so why is slowing down at C? The reason is because now you start having the mortality rate gaining momentum. So the mortality rate will start gaining momentum. So the mortality rate will start gaining momentum. So the mortality rate will start gaining momentum. So you have mortality rate gaining momentum. So whenever you've got mortality rate gaining momentum, therefore those bacteria are going to start dying in large numbers. So those bacteria will start dying in large numbers. That should be a conclusion. We know firstly we have mortality rate gaining momentum. Therefore, this will lead to a lot of bacteria dying in a large number. And because the bacteria are dying in a large number now, that's why the graph is starting to become a bit constant there at C. Because now we've got more death that's increasing. More death are increasing. And also, the mortality rate gains momentum. So the reason for that could be the bacteria, maybe this environmental resistance. Mostly we use environmental resistance. So there could be environmental resistance that's affecting those death of bacteria, or maybe there's no more food, or they're fighting for food. Whoever gets to get the food first survives. So meaning there's low levels of food. So the environment is fighting now. So that will be the environmental resistance. So to put it in short, to explain for 1.4.3, you will say that the mortality rate gains momentum. This could be due to environmental resistance, and then as such, the bacteria are starting to struggle getting food. Therefore, now they start dying in large numbers. That would be foreseen to explain 1.4.3. Now we go to question number 2. Firstly, you must know the topic. That's gaseous exchange. So now we're exchanging gases. It's internal one, this one. So remember, we've got two gases, oxygen and carbon dioxide. Always remember, carbon dioxide will be taken out from the blood. Oxygen will be taken in the blood. Don't forget that. CO2 is taken out of the blood. We have been shown here that this in the middle, that's the blood capillary. So now you must look at the arrows. Remember, CO2 will be taken out from the blood, but oxygen will be going inside the blood. So look at the arrow. See this arrow here? This arrow is showing us that whatever the gas is here is going away from the blood. Same here. The same gas also is going out from the blood. So that gas that is at Y, wherever the gas is at Y, is going away from the blood. And we know that CO2 is the one that goes away from the blood. So meaning gas Y will be CO2 or carbon dioxide. So gas Y will be CO2 or carbon dioxide because the arrows are showing us that it's going away from the blood. Now X, they're showing us that X is going in the blood. See, they're going inside. Even here, it's going inside, meaning X is the one that is going inside, meaning X will be oxygen because O2 will always go inside the blood. CO2 will be taken out. So 2.1.1, they were asking us what is gas X and Y. So X will be oxygen, Y will be CO2 based on the arrows because CO2 will go away from the blood, but O2 will go inside the blood. And then let's go to 2.1.2. Name the physiological process that is responsible for the movement of gases as shown by the arrow. Okay, remember, during this process, for the gas to move, they must undergo what we call diffusion. So for the gases to move, they're going to undergo what we call diffusion. So they'll be diffusing from one area to the other one. So the gases are going to undergo what we call diffusion. So they'll be going from one place to other. So they use what we call diffusion. So diffusion is the process that will be occurring there in the lungs, in the alveoli. That will be for 2.1.2. Then let's go 2.1.3 now. 2.1.3. Name two different ways in which gas X will be transported in the blood. So basically they're asking us two ways in which gas X will be oxygen. So they're asking us two ways in which oxygen will be transported in the blood. So you need to know there must be two ways that it will be moved in the blood. First of all, it will be dissolved. It will be dissolved just as by D. It will be dissolved in the blood plasma. So that's how they mostly transport it. It's going to be dissolved in blood plasma. So it will be dissolved in blood plasma. So it will be dissolved in blood plasma. So it will be dissolved in blood plasma. That will be the first point you can say. That's how they're going to transport it. It will be first dissolved in the blood plasma. So it's going to be dissolved in the blood plasma and the water. Sometimes they can also put in water as well, or a watery solution. So it will be dissolved in blood plasma and water. That'll be the first point you're going to have there, because they're requesting us to do too. So second point would be it is bound to what we call hemoglobin. So it's bound to hemoglobin, which allows breathing. So hemoglobin will transport the oxygen. So it's bound to what we call hemoglobin. So that's how oxygen will be transported in the blood using those two methods. So it will be bound to hemoglobin. So that's how oxygen will be transported in the blood. So this would be your two options. Then now we're going to 2.1.4. They're asking us which protein plays an important role in the transport of gas, which is CO2. The protein that will be playing a very important role there is hemoglobin, because hemoglobin is a protein. So the protein that will be playing a role there is the hemoglobin. So hemoglobin is the protein that will be binding CO2 there. So it's hemoglobin. So it will be binding CO2. It's hemoglobin. That will be the protein there. So that will be that. And then lastly, 2.1.5. They're asking us to find three ways in which three structural adaptations for an efficient gaseous exchange. Okay, so three ways in which the structure in the lungs can be adapted for gaseous exchange. Okay, just give you guys the 3 points, and then I'll explain how each will help. So it's 2.1.5. So the three ways that it will help. Okay, first of all, the alveoli that is there in the lungs increase surface area. So alveoli in the lungs there increase surface area. So alveoli increase surface area. So alveoli will increase surface area. So alveoli increase surface area. That'll be the first point. Surface area. So alveoli will increase the surface area there in the lungs. Surface area. That will be the alveoli. So alveoli will increase the surface area. So that will be the first point. And then when it increases the surface area, this will allow gaseous exchange to be efficient. So it will allow more gas to move. Yeah, it will allow more gas to move. So this will allow more gas to move, and then therefore allowing the whole process to be efficient. So this will allow more gas to move, more movement. This will allow more movement of gas, more movement of gas, more movement of gas. So that will be the first point, movement of gas, because the aim is to allow this gas to move there. That will be the first point there, more movement of gas there. So second point, remember we've got the ask for three ways. First, alveoli will increase the surface area. Number two, the membranes which are involved must be thin. The membranes must be thin. So the membranes must be thin. That will be the second point. The membranes must be thin. The membranes where the gas exchange is occurring must be thin. That will be the second point. So the membranes must be thin. That will be the second point. Must be thin. Must be thin. Okay, so I'm not trying to squeeze some space for that there. must be thin. That'll be that. And then from there onwards, so the advantage of them being thin, that it will minimize the distance that the gas will travel. So it minimizes distance, minimizes the distance that the gas will travel. So that will move. Okay, let me try and get some space here. Because I'm gonna struggle to get space here. Let me try and erase that so I can get more space to finish the point that I was raising. So that will minimize the distance that the gas must diffuse now. So to minimize distance, the gas will diffuse. Gases will diffuse. That will be the second point. Diffuse. So that's why these membranes must be thin. Will diffuse. That's why the membranes must be as thin as possible. Okay, third point now will be that the surface must be moist. Yeah, my there it looks so terrible. The surface must be moist. 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 So the surface must be moist. The surface must be moist. The surface must be moist. That will be the third point. The surface must be moist. So the reason why the surface must be moist is that it will allow the gas to diffuse in the moist environment. This allows gases to diffuse in a moist environment. This will allow gases to diffuse in a moist environment. So it will allow gases to diffuse in a moist environment. So it will allow gases to diffuse in a moist environment. Before they can even go to membranes. So it will allow gas to diffuse in moist environment before they go to membranes. Diffuse in moist environment. So allow gas to diffuse in moist environment. So I'm gonna put this environment there. Okay, environment. So this will allow them to diffuse in moist environment before they go to other membranes. That will be your last point. Environment. So that will be question number 2.1. Okay, that covers 2.1. All the 3 points I've got. Alveoli will increase the surface area. The membrane must be thin, and then lastly, the surface must be moist so that the gas can move around the moist environment. So those will be the 3 points that you're gonna put for that question. So this one will be for the previous one, so that you guys don't get confused with that. So that will be question number 2.1, and then from there onwards we go to 2.2. So 2.2 now, we're given the Malpighian body, so it's a Malpighian body, and they're asking us 2.2.1 what was name the part shown in the diagram. That's the Malpighian body. So most of the sometimes they'll ask you guys to draw it or to label it. So they're even asking you guys to name give the name of it. But sometimes you'll get questions where they're gonna ask you to draw and also label it. So that's the Malpighian body. So Malpighian body, we know it has got those two arterioles. So the one that will take the blood in is the afferent one. So mostly I call it the A, is the afferent one. Then the one that will take away will be the efferent arteriole. So I've got the afferent, which will take the blood in. Efferent will take the blood out. So here they're asking for part A. Part A, I know that will be the afferent arteriole. So the difference will be the A there. So it's the afferent arteriole. Afferent. That will be the afferent arteriole, part A. That will be the afferent arteriole. That's part A, the arteriole. That's our part A. The afferent arteriole is our part A there. So that will be that. And then they're also asking us for part C. Where's C? But they didn't ask for B, will be efferent. So they're asking for C. C is inside there. That will be the glomerulus. C 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 will be the glomerulus. And then they're asking for process D. Also, process number D is occurring inside still under the Malpighian body. If it was occurring after the Malpighian body, that will be the second process, which is the tubular reabsorption. So they're asking about the process which is occurring inside. It's occurring inside our Malpighian body, and the process that occurs in the Malpighian body is the glomerular filtration. That's the first step that occurs in the nephron. That's glomerular filtration. That's the first one that occurs, which is the glomerular filtration. That's the first step that occurs. Is glomerular filtration, and then the one that will follow it will be tubular reabsorption, and then we're going to have tubular secretion, and then lastly we'll have excretion itself. So that will be that. That's glomerular filtration because it's occurring in the Malpighian body. That's the first step. Then second step will be tubular reabsorption. Then third will be tubular excretion. Okay, 2.2.3, we're being told describe the homeostatic functioning of a nephron if a person consumes excessive amounts of water. So I mean they've taken in a lot of water. So the process where we control water is called osmoregulation. So the process that is so if you want to add more points, you will tell us that the process where we control water changes in the body is called osmoregulation. That's why we control water changes in the body. It's called osmoregulation. That should be the first point. If you want to add more points there, so whenever you're controlling a water change in the body, we call that osmoregulation. So during whenever there's too much water being consumed in, so we call that overhydration. Whenever you have too much water, it's called overhydration. But if I'm losing water, we'll call that dehydration. But here the thing about having more or excess water, which will be overhydration. That will be our second point. When I have overhydration in the body, so when I have overhydration in the body, so meaning I've got too much water, that's called overhydration, which is too much water. Okay, I realized I was not recording when I was doing other points. Okay, so this will be the whole process that will occur. You're going to have osmoregulation, which will occur, and then from there onwards, you're going to have overhydration, which is too much water. Then you will have high levels of water. Then the pituitary gland or the master gland will release hormone ADH. This will cause the walls of collecting duct and distal cavity tubule to become less permeable. That will be another point. Therefore, less water will remain in the blood. Now, more water will leave the body as urine. Those will be your points in that order. High levels, we call that process of controlling water, osmoregulation, which should be your first point there. Then when you have too much water, it's called overhydration. Therefore, we're going to have high levels of water. Then the pituitary gland or the master gland will release ADH. This will cause the walls of collecting duct and distal cavity tubule to become less permeable. Therefore, less water will be in the blood. Then more water will leave the body in the form of urine. That is for having too much water. For having less water, we'll call that dehydration. And then again, the pituitary gland will release ADH. But now for less water, the walls of collecting duct and distal tubules will become more permeable. That's for less water. Therefore, more water will remain in the blood. And therefore, more or less water will leave the body in the form of urine. So less water will leave the body in the form of urine, meaning more water will be saved for us to maintain water because we're undergoing dehydration. That is if they ask you about less water. Also, they're going to ask you guys tomorrow about salt, also about pH, because there are three homeostatic controls for grade 11. There are three homeostatic controls for grade 11. It's about pH, salt, and water. So you guys must know all those three. Here they ask about water. In the next test, they might ask about salt or about pH. So you must know all three of them. So let's go to 2.3 now. 2.3 is a different topic now. We're going to ecology now. So I've been told about the interaction between a hare and a lynx population. Okay, a hare, we know that's like typical herbivore. Then this one will be the one who will be eating the hare. So this guy will be the predator. The predator is the lynx. Then this one will be the prey. So the hare is the prey. And then the lynx will be the predator. So meaning the lynx will be eating the hare. So we're given the graph here. The hare it's blue and the lynx it's on a bit reddish. So this one is blue, which is our hare. So at the beginning, we've got a high population of the hare, and then the lynx is still a bit low. And then now the lynx gets increased, the hare goes down, and then that goes up and down until at the end, again the lynx is the predator is going down, but the other one is going up. So meaning this will be didn't ask for this one. So the highest point that you're gonna get here, it came in the biological terms. Was it the multiple choice? I don't remember. Somewhere in the previous questions. So that population there, that point that you have there, it's called the carrying capacity. They didn't ask for it here, but it's called the carrying capacity. So here they're asking us to describe what is happening between the hare and also the lynx population in this two. So I'm gonna just explain to you guys in my own words. You guys can use your own words. I think they always accept every word. So what's happening here? That's for 2.3.1. So I want to explain that in my own words as to what's happening now. So I want to explain that in my own words what's happening. So as you can see again on this graph, at the beginning we've got the hair being high, and then the lynx will start increasing at some point. So my first point here will be that initially we had a high number of hair population. So initially we had a high number of hair population based on the graphs. So initially we had a high number of hair population. That's my first point. Initially we had a higher number of hair population, and then from there onwards the number of lynx will start to increase because they have more food. By food we're referring to the hair. So the more the hair population is there, the more the lynx will have more food to eat. So the second point will be the lynx population will start increasing. So that's why it's increasing the lynx population. So this population of lynx is increasing because they have more food to eat. The food here will be the hair. So now from there onwards, the lynx population will start to go down here. See, it's going down again. The reason why the lynx population starts going down again is because they've eaten too much of the hare population, meaning the numbers of the hare will start going down. The more the number of the hare starts going down, this will also affect the lynx. That's why here we're having the lynx going down, because the hares are becoming few for them to eat. And then now again, at the same time, when the lynx goes down, the hare will start going up, because now they have got less people to eat them. That's why they'll start making more babies, because they've got a few lynx around. And then this cycle will continue again. The more the hare population increases, the more the lynx will also increase, because they'll be having food to eat. But the more they start eating, and the more of the hare, then the lynx will start going down. So every time when you see the lynx going down, it's because the hare has went down. And the moment the lynx goes down, the hare will go up. So that will be me using my own words to explain what's happening there. So you guys must be open to use your own words, interpreting what you're seeing on the graph. Don't forget to include the hare and the lynx as your point of reference. So now let's go to calculation. Okay, I'm not a fan of this type of calculations. I'm a big fan of math calculations. This type of calculations, yeah, they can become difficult when they want to be. Okay, let's analyze what they're asking us to. I'm not a big fan of this. They want us to find the percentage decrease of hair population between 1990 and 1995. So we're going from 1990, which is this point, to 1995, that's that point. Let me erase what I was writing from the previous question. I want to see if I can interpret everything here and see what's happening. So they want us to go from 1990 to 1995 of the hair, on the hair, the blue ones. We're going to focus on the blue ones. So on 1990, we had the blue at 400. So at 1990, we had the blue at 400. That was 400. So we've got the hair at 400. That will be the first one. And then what is the hair at 1995? 95, it's somewhere around there. It looks like in the middle a bit. So if it's in the middle, that will be 250, because the other one is 300, so it'll be 250. Yeah, based on that should be 250. Okay, that would be 250 based on that. So from there onwards, we need to also interpret. I've got 250 there. So for me to find the calculations, I'm gonna use the final one, which is 1995, which is 250, and then you minus that by the initial one, which is 400, and then you divide that 400 by the difference. So difference will be what you're having. So difference will be what you are having. So the difference we know it's 400 and 250. So 400 minus 250. So it will be 400 minus 250. 400 minus 250. That will be 150. So that will be the difference between the two. So you're going to divide that by the difference, which is 150, which you'll get from 400 minus 150. And then from there onwards, you will divide the whole thing by what you had initially, which was 400, or 1990. So you divide that by what you had initially, which is 400, or the 1991. So you divide that by what you have initially, and then you're just going to multiply the whole thing by 100 because it must be percentage. So you multiply the whole thing by 100. So from there onwards, just do them step by step. It will be 200 minus 200, so it will be not 200, 250. So it will be 250 minus 400 divided by 150. 400 divided by 150, that's going to be 2, I'll put as 2,67. I'm going to put as 2,67, and then I'll divide that whole thing by 400, and then you're going to multiply that by 100. And multiply that by 100, and then from there onwards, let's just save time and just do the whole thing once. 250 minus 2,67 divided by 400 times 100. Okay, I'm happy that I'm getting a value that's below 100 because I want to get those 100 percentages, whatever. So I'm getting 61.8% as my answer. Hope that is accurate, but yeah, that's what I'm getting. So that's it. That should be the answer there. It's 3 marks. Okay, that should be fine. So I don't know how I'm gonna make it, but so it means that the population is decreasing by 61.8% during that time frame, which makes sense because it was at 400, now it went to 250. It didn't decrease, 250. It didn't decrease that much, so it decreased by 61%. Okay, that makes sense. That's a big decrease, though. You would expect at least for it to go a bit down or what, or up. So that would be that. So let's go to question number 3 now. It's an investigation. So they did an investigation to determine the effect of smoking in males on the risk of lung cancer. The full procedure was followed. We had 400 males in the investigation, and then only males who smoke regularly were included. And then all males in the investigation, they smoke same. So all males, they were smoking the same cigarette. That's a control. So this is the control. They were smoking the same cigarette. That's a control. And then they use male of same group. Those are the controls now. So it's good to have controls because at least it allows the thing to be accurate. And then that's it. Then they gave us a table. Remember when you get a table like this side, even in maths or physical science, we call this the X. And then the Y. That's the X and the Y. So 3.1.2, state the dependent variable. Dependent variable is the X. So that's your answer. Wherever is the X, it's your independent variable. Wherever is your X, your independent variable. So the answer would be number of cigarettes smoked daily. If they ask for dependent variable, would be your Y or risk of lung cancer. That would be your dependent. But because they're asking for independent, the answer will become number of cigarettes smoked daily. So it will be number of cigarettes which are being smoked daily. Number of cigarettes SM smoked daily. SMD. Just call it SMD smoked daily. Just go and copy it as it is. Number of cigarettes which are being smoked daily. I'm running out of time. I've got 20 minutes left. And I'm worried about the 20 minutes because I want to keep this under 1 hour. Like you guys will be requested to keep it under 1 hour. So 3.1.2, state these 2 ways in which the validity of the, okay, you guys want to show how you can increase the validity of the investigation. So you can use any type of thing that you can think of, whether it's physical science or any experiment. We know that all the time you need to make sure that at least we have we need to improve. So the one that we can do is to improve the sampling measuring technique. So just improve the measuring technique. So it'll be the improve measuring technique now. So improve the measuring technique, how you are measuring this risk of lung cancer. So improve the measuring technique. That will be one way to technique. So that will be the one way to improve that. So improve the measuring technique. So that will be one way you can improve the validity technique. And then also, so that we can also, so they choose 40 males, and they didn't say anything about being random. So we need to also choose males at random. So just choose males at random. Don't choose the males that you know. Just choose any male, regardless of who they are. So choose males at random. So you need to also choose males at random. So choose males at random. They didn't say anything about the males being chosen at random. So choose males at random. So those are the two ways you can improve the validity of the investigation. That's for 3.1.2. And then for 3.1.3, they're asking, other than repeating the investigation, state one way in which the reliability of the results can be increased. For you to increase the reliability of the experiment, mostly we repeat the investigation. Mostly we increase the, so we repeat the investigation, or you can increase the sample size. So you can increase number of males in the study. So you can increase number of males in the study. So these are the two ways you can increase the sample size or repeat the investigation. So you're going to increase a number or no of males in the study. That will be one way to improve the reliability. Increase a number of males in study. That will be one way to increase the reliability of the investigation. Increase number of males in the study. If you're doing females, same thing. You increase the number of females in the study. Okay, 3.1.4 now. They're saying that smoking has a potential to destroy cilia in the breathing system. Okay, explain the effect on the breathing system when cilia are destroyed. Okay, it's 3 parts, so I need to get at least 3 points. So whenever you destroy the cilia, things like your dust, your germs, remember that things can go into your lungs. Things like your dust, your germs, and then also and mucus, things like those, and mucus will not be removed easily, and mucus won't be removed easily because cilia is damaged. Won't be removed easily because cilia is damaged. Won't be removed easily. It won't be removed easily because cilia is damaged, so it won't be removed easily because I've damaged my cilia. It won't be removed easily, so the cilia won't be able to work very well anymore to remove them. So meaning now in my lungs, I'm going to be having things like dust in lungs in them. And whenever you've got mucus in your lungs, that's when people are coughing so bad because they're having a mucus blockage. That's because the cilia is damaged. And then that will be the first point, that dust, like dust, your germs, your mucus will not be removed. So now, besides that, also the surface area of gaseous exchange will be infected. So the surface area of gaseous exchange, just call it surface area SA, the surface area of gaseous exchange, surface area of gaseous exchange, GE, gaseous exchange will be infected. The surface area of gaseous exchange will be infected. The surface area of gaseous exchange will be infected. That will be your second point. Surface area of gaseous exchange will be infected. So the cilia are very important, guys. Whatever happens, always try to protect your cilia by all means. So whenever you've got surface area being infected, this will lead to poor supply of oxygen. So this will lead to poor supply of oxygen because the surface area is damaged or infected. So this will lead to poor supply of oxygen. And whenever you've got poor supply of oxygen, therefore you struggle to breathe because you've got less oxygen coming to you. So this will lead to poor supply of oxygen. Of course, this will lead to difficulty in breathing. So this will lead to difficult breathing because I've got less oxygen that I'm getting. This will be difficult breathing. So this will be a 3 points to explain what happens when cilia is damaged. Difficult breathing. So that's why cilia is important. got the mucus, your dust are gonna enter. Also, the surface area will be infected, meaning when I have problem with oxygen now breathing. I'm gonna press breathing there. Poor supply of breathing. Yeah, I'm trying to squeeze everything now. That'll be breathing there. Okay, that'll be that. So now let's go to 3.2. So for 3.2 now, we're given a graph which shows the concentration of certain substances as they pass through the nephron. Okay, we're going back to the kidneys again. So we've got region A. Remember, region A is in the Bosman capsule. That'll be the glomerular filtration around there. Then you're gonna have tubular reabsorption around there, and then you're gonna have tubular secretion, and then lastly you're gonna have excretion as the first process around there. So they're asking us name the process that occur in region B. Region B, second one, that should be tubular reabsorption. That should be tubular reabsorption. That will be tubular reabsorption. So occurring under number B. I'm gonna put reabsorption there. So it's gonna be tubular reabsorption, the second process in the nephron. So in the previous question, absorption there. In the previous question, they asked us about glomerular filtration, which was the first process under Malpighian body. So here they're asking about the other one. So maybe in the next test, you guys are going to get about tubular excretion, or the last step, excretion itself. So it's always good to know all the steps, guys, because they can come in anytime, any day. Explain one way in which the Bosman capsule is adapted for its function. Okay, one way. Okay, one way would be it's cup shaped. So that Bosman capsule is what? Cup shaped. It's in a cup format. It's like this. It's a cup shaped. So it's a cup shaped. So it's a cup shaped. It's a cup shaped, and this being cup shaped, it allows glomerulus to do filtration. So being cup shaped allows glomerulus to undergo filtration. So it undergoes and allows glomerulus to do filtration. So that will be the advantage of Bosman being cup shaped. It will allow glomerulus to do filtration. So that will be that, to do filtration. That will be your one way. So the other ways that is just got different things as well there. So that will be your one way of how to undergo, allow what do you call it, filtration by glomerulus, because it's cup shaped. And then 3.2.3 letter A. So for letter A, they are saying, using the graph, discuss the possibility that the person will suffer from diabetes. So remember, for a person to suffer from diabetes, a lot of glucose will need to be there in the blood, or a lot of glucose will need to be there in the last step. So meaning in the last step here, you need to have a lot of glucose. But based on this diagram, we don't have a lot of glucose here. So glucose is ending around here in second region. So we don't have a lot of glucose there. For us, if you have a lot of glucose in region number 4, this will increase the chances of you getting diabetes, because meaning your kidneys are absorbing a lot of glucose. So here we have got no glucose in region 4. So to answer this one, you will say, okay, first of all, no glucose levels, no glucose in region 4 or region D, no glucose in region D. So there's no glucose in region D, no glucose in region D. So because there's no glucose in region D, therefore there's less chance of us having glucose in collecting duct. So So there's less chance of having glucose, less chance of having glucose, less chance of having glucose in collecting duct, of having glucose in collecting duct, glucose in collecting duct, glucose in collecting duct. So there's less chance of having glucose in collecting duct. So if you've got less glucose in collecting duct, therefore this is less chance of diabetes, less glucose in collecting duct, meaning the person in the diagram has less chance, or the possibility is very rare, less chance of having diabetes, less chance of having diabetes, or it's rare, because as long as region D here, that's where you're going to get your collecting duct. So if you're having a lot of glucose towards the end, therefore the kidneys are in trouble, less chance of having what do you call it, diabetes, diabetes mellitus, which is DM, diabetes mellitus, that's DM. Then let's go to letter B now. So they're asking what is the possibility that the person will suffer from dehydration. So remember, dehydration is what? The loss of water. So dehydration will be the loss of water. Let's check. Dehydration is the loss of water in the body. And if there's too much water, which is under like the last step here, if there's a lot of water that is going to the kidneys, therefore you're gonna have a problem. Let's check the water levels. So we've got urea, it's high at the end in region 4. We've got a high levels of urea in region 4, which is fine because urea is a waste, it must go out. Urea is a waste, it must go out. But this is a problem. We've got also high levels of water in the last stage. You're supposed to have like low amount of water as possible there. We have a high level of water at last stage. So the levels of water are high. So let's say moderate to high. I'll say moderate to high because the highest would be urea, but we've got moderate to high, moderate to high levels of water. So we've got moderate or high levels of H2O in region D. So we've got moderate or high levels of H2O in region D, in region D. So we've got that high level in region D. So now the problem is, if you've got that high level of water in region D, therefore more water, so meaning this means that more water will be leaving, more water, H2O will leave kidneys, kidneys in the form of urine, will leave kidneys in the form of urine, will leave kidneys in the form of urine, will leave kidneys in the form of urine. So they'll leave kidneys as urine, will leave kidneys as urine. And if you've got more water that's leaving the kidneys, therefore there's a high possibility, therefore I'm going to put that, therefore there's a high possibility, or high moderate possibility, there's a high possibility that this person will be undergoing dehydration because they're losing a lot of water. There's a high possibility that the person will be losing water, high possibility of losing high possibility of dehydration because they're losing a lot of water, high possibility of dehydration because more water is going to be released in the form of urine. So high possibility of dehydration. So that'll be your answer. So they ask us about diabetes and also dehydration. So for diabetes, there's a less chance of it happening here because there's less glucose at the end. But for dehydration, it's high because water is a bit high at the end. So if glucose was also high here at region 4, this person has a big chance, or they're gonna end up having diabetes because there's so much glucose in their blood. Here they've got less of it, but the water is still high. I mean, they've got too much water in them. So that would be the answer for letter